Okay, so hello everyone. Today I'm gonna show you how to sketch a graph of a rational function. To begin, I'm gonna tell you the 5 steps, which are find x and y intercept, get the vertical asymptote, the horizontal asymptote, the substitute the numbers, the closest numbers on the asymptotes, and then sketch the graph with all the elements that we got previously. So to get the first step done, you need to get x and y intercept. To get x-intercept, you must factorize the upper part of the function. So if we factorize, it's gonna be two numbers that multiplied give us -3, and the sum will give us +2. It's gonna be x plus 3 times x minus 1. We got them inside a parentheses, so we're gonna change their sign, and it's gonna be x equals -3 and x equals 1. Then to get the y-intercept, you must substitute every variable x with the number 0. So this is gonna be 0, it's gonna be 0 right here, 0 and 0. So the only coefficients that are left is -3 and -2. So if we divide y int, it's gonna be -3 over -2, which equals to 3/2. So here we got our first step. Then to get the second one, as it is to get the vertical asymptote, you must factorize the lower part of your function. So two numbers that multiplied are gonna give us -2, and some are gonna give us -1. It'll be x minus 2 and x plus 1. Here we got our second step. The third step will be get the horizontal asymptote. In order to get the horizontal asymptote, we have to get the seeing the exponents of our function. When we got the same exponents in the upper part and the lower part, we know that y is gonna be equal to 0. So here we know that y is equal to 0. Then we can start sketching the graph. So the final part is gonna be easier for us to complete. 1, 2, 3, 4. 1, 2, 3, 4. Right here. 1, 2, 3, 4, 5. 1, 2, 3, 5. Okay, so here we got our x-intercepts. So we got one in -3 and the other one in 1. We got y-intercept in 3/2, so it's gonna be right here. We got our vertical asymptotes. So here I forgot to change the sign. X equals 2 and x equals -1. So we're gonna put the asymptotes. It's 1. It's over here. 1, 2, 3, 4, 5. And into 1, 2, 3, 4. when you got the same exponent on the upper and lower part, you have to divide the leading coefficient of the higher part over the leading coefficient of the lower part. So here it's not gonna be 0, it's gonna be 1 equals 1. So our horizontal asymptote is gonna be right here. Okay, so in order to know where the graph is going to go, if upward or downward, we have to get the closest number to the asymptote. So if right here we got the asymptote in -1, we need to get the closest number to the right and to the left. So right here is going to be number 4. So what are we gonna do with -1.1? We're gonna substitute every single x that we got right here in the parentheses, so we can know if the sketch will go downward or upward. So let me begin. -1.1 plus 3 -1.1 minus 1 over the lower part, that's this one. It's -1.1 minus 2 and -1.1 plus 1. So once we got this, all we need to know is if the number right here is going to be positive or negative. So -1 plus 3 is going to be a positive number. -1 minus 1 is going to be a negative number. Right here, -1.1 minus 2 is going to be negative. And right here, -1.1 plus 1, it's going to be negative. So if we multiply positive times negative, it's going to be negative over negative and negative, it's positive. So when we get this, we get a negative number. So I'm going to erase this. And we know when the graph is closest to -1.1, the graph will go downward, right? Just like this. Then let's do it with -0.9. So here we got -0.9 plus 3 times -0.9 minus 1 over -0.9 minus 2 minus 0.9 plus 1. So we're gonna do the same procedure right here, and it's -0.9 plus 3, it's gonna be plus. Right here we're gonna get minus, here we get minus, and right here we get a plus. So this right here is gonna be plus times minus, it's minus, over minus times plus, it's minus, which minus over minus, it's equal plus. So we know that our graph, when the graph approaches to -0.9, is gonna go upwards. Then, okay, and so here we got the graph already finished. All we did is just substitute the numbers of the asymptote with the closest numbers